All right, folks, let's go ahead and get into lipids, also called fats in general. They're still going to contain carbon, hydrogen, oxygen. Some of them have phosphorus, but most of the time you see carbon, hydrogen, oxygen. They're going to be insoluble in water. So yes, some folks can relate that to what we already saw, some terms like hydrophobic. Okay? They do not like water. Remember, our example was oil floating on water. That's the reason why they don't mix. There are three main types that we're going to focus on: triglycerides or fats, phospholipids like our phospholipid bilayer that we're going to learn about when it comes to cells, and steroids like cholesterol or estrogen or testosterone, which is going to be a part of physiological processes in the body. You also have echinoids, which we do not talk about, and these help a lot with cell signaling and for signaling molecules, so we don't have to get into those details. I just want to add that in here just in case someone's on the interweb and they're like, what's this? I'm like, yeah, it still is a lipid. Now, the reason why we can't have specific monomers for lipids is because there's three different types, and each type has their own form of a monomer. Okay, folks, and that's what we're going to get into next. So let's start off with triglycerides. These are called fats, and there also can be oils. So if you're going to be fat, you're going to have it be a solid triglyceride. If it's oil, it's going to be a liquid triglyceride. Okay, now how are these actually made? First things first, they're going to have glycerol. So here's the glycerol portion. And you see that glycerol has little oxygens on the end as well. And each of these oxygens is going to be attached to a fatty acid. That's what I'm doing as FA, fatty acid. So you have glycerol and 3 fatty acids. That's how you get triglycerides. So the tri means the 3 fatty acids chains, and the glyceride means the glycerol that they're attached to. Okay, folks? And so that's where we're kind of have the monomer, if you will, for triglycerides. Not really a monomer, it's just what a triglyceride is. I'm just trying to make connections for you. Okay, folks? So again, 3 fatty acids and a glycerol. Now, you don't have to draw it this way. I'm not the perfect drawer, but I do my best. I'm just going to say glycerol and fatty acid chains. That's how we draw. I wouldn't draw it as fancy as that. Okay, folks? Now, what are the main functions of triglycerides? Energy storage, insulation, protection, so many different things. Think about all the fat and how you use fat in your body as well. Okay? Now, when we're thinking of insulation, you can also bring it back to thermal regulation, helping with heat. So just keep that in mind. Another thing we notice when it comes to triglycerides are that there are 2 types. There are saturated triglyceride fats and there's unsaturated triglyceride fats. And then let's think about what's the difference between the 2. If I were to take all this little accoutrements off, and I was looking at this and like, what's the difference between these? Well, these are just fatty acid chains, okay, and this one's highlighted. These are same, this one's highlighted as well. What's the difference between this one and this one? Here we have covalent bonds, just single lines that we see here. And here we have covalent bonds that look like this. And that is a covalent bond that is now a double bond. So a single bond has 1 line, a double bond has 2 lines, a triple bond has 3 lines. And we're seeing a double bond when it comes to unsaturated fats. So guess what happens when you have that double bond? It creates a kink in the overall fatty acid system. So you have your glycerol here, you have your fatty acids here, your fatty acids here, and then you have one that kind of creates a kink. So if I lined all these up together, they will be able to insulate and smash together to make them really, really close and tight to one another, right? But if you have any kind of kink, it's not going to allow for that same type of packing. And so guess what? They're not going to be as close. And so what does that mean for us? It means we have fluidity. And if you have fluidity, then you can have things flow. And that's great for cardiovascular health. If you have things that are packed together, like the regular saturated fat that you see here, then again, you can create arteriosclerosis and fat that is going to be attaching to your arteries, for example. But the unsaturated fats are healthier because at the end of the day, they are not going to pack the same. They can actually move through the system the same and be processed differently. Okay, so that's the difference. Saturated fat means it's saturated with hydrogens. Okay, unsaturated fat means it has a kink or a double bond, and so it has less hydrogen. That's what we want to think about. Okay, folks? Now, let's go ahead and put the cheese on the cracker. If you're eating a lot of unsaturated fats, like olive oil or nuts or fish, then you definitely are going to have an increase in low density lipoprotein or good cholesterol. Okay? Because again, you have that fluidity, movement in your actual system. And if you have saturated fats, like we talk about the butters and meats and everything like that, especially if you're dealing with trans fats, which is basically a modified, like chemically modified in a lab type of fat, then you actually can have an increase in cardiovascular issues. Just keep that in mind as well. So if you want to maintain your health, exercise, don't eat as many saturated fats, increase the amount of unsaturated fats. That's one general easy way they always tell you, but it depends on each person's body. I just always say unsaturated fats, you're going to have more good cholesterol. Saturated fats, you're going to have more high cholesterol. Okay? So just keep that in mind. And of course, I wrote them wrong. So let's just talk about them really quick. So just because I did write it wrong. This is supposed to be HDL, and this is LDL. You have high density, H is for high density lipoprotein, low density lipoprotein. So if you have something that's high density, it's going to be easier for your body to recognize it and therefore process it. If something is low density, it's more inconspicuous. It's going to be harder for your body to detect. And guess what? They can accumulate and form plaques. So we don't want the low density lipoprotein. So just keep that in mind. All right, folks, let's move on. All right, next is going to be the phospholipids. These are basically triglycerides that are modified. So how are they modified? We know triglycerides are the glycerol with the 3 fatty acid chains. Well, phospholipids are basically going to be your glycerol with 2 fatty acid chains. Okay, so that's how they're modified. That's why, they always are next. And again, because you have glycerol and you have 2 fatty acid chains, that's going to allow to have one area that can actually be considered polar. Okay, so let's go ahead and write what the fatty acid will look like. So again, we have our glycerol and we have 2 fatty acid chains, and that allows us to distinguish between polar and non-polar regions of the phospholipid. So the polar head, where the glycerol head is going to be, has the ability to be polar. That means it's going to have some areas of partially negative and partially positive charges, and it can interact with water, for example. And if it can interact with water, we know it's going to be hydrophilic. And then we have these fatty acid tails that we know are going to be non-polar. So they don't have any partially negative or partially positive portions here. These are all just plain old covalent bonds. And because of that, they're going to be non-polar and considered hydrophobic. And the beauty of a phospholipid is that due to their structure, it dictates their function. So let's go ahead and go to this one really quick. If we go ahead, no, let's go to this one. I have a phospholipid again. I'm going to have the glycerol with the 2 fatty acid chains. And because this is going to be hydrophilic, it has the ability to interact with water. And of course, the hydrophobic portion, or the nonpolar region, does not want to interact with water. And so when it comes to cells, we need a barrier. We need a barrier on the outside that can interact with other cells. And of course, our bags filled, we are just bags filled with chemicals and water, right? But we also need something to interact with the inside of the cell, which also has its own cytosol. So we create a bilayer. And the bilayer is made of phospholipids. And let's see how it's arranged. We have all of the polar heads pointing outside of the cell and inside the cell. That's the beauty of it. While all the nonpolar regions form this little bilayer so that it's not even interacting with water at all. So some folks will be like, well, how do I get things that are polar or nonpolar across the actual plasma membrane for these cells? That's what we get to talk about in chapter 3. And a lot of times it's going to come from the fact that you do have proteins that are going to be embedded into the plasma membrane to help us get through that as well. Okay, folks, so just keep that in mind. And this is what it looks like here. This can be the outside, this can be the inside of the cell, and as you can see, there's a non-polar region. And this is going to be extremely important for cell membrane structure. That's how we actually form a barrier for our cells and how we exist. Now let's go ahead and talk about our last group, which is going to be steroids. And this is going to consist of 4 interlocking ring structures. I don't expect you to draw this. You know me, I'm just going to just put a couple circles. And I know that's going to be, quote unquote, the monomer precursor for steroids. And the most important steroid is going to be cholesterol. Cholesterol we see embedded in the actual lipid bilayer as well to help with the actual packing of the lipid bilayer to make sure it's not extremely fluid. And then also these steroids, especially cholesterol, is going to be made by the liver. So just want to keep that in mind as well. Cholesterol is going to help stabilize the plasma membrane, but also this little 4-ring structure here is important as a starting material for estrogen, testosterone, cortisol, okay? If you want to digest fats in the body, bile salts as well. All of it comes from this little version of a monomer for steroids. So we want to keep all those little details in mind. And then, of course, if you were to look at this table, if you look at fat/lipids, we know they can have carbon, hydrogen, oxygen, phosphorus, nitrogen. It just depends. It could be cholesterol, steroids, triglycerides. The function is going to be phospholipids in the cell membrane, fuel source, energy as fat for insulation, thermal regulation, and then any extra notes you want to add. Okay, folks, so that's really how you want to be going through this. Yes, it's a lot of little details, but make sure you have an ability to just fill out a table like this first. Okay? And as you can see, the nonpolar head here, I just want to throw this back out there. It does have phosphate, which includes phosphorus, you see. And it does have nitrogen groups that can be attached to it because other things can be attached to something that's polar. It can make other interactions. You just keep that in mind, folks, for lipids. Let's move on to one of the bigger pieces, which is proteins.